Hello everyone, and welcome to this Heat Roadmap Europe webinar in the series of webinars in the Heat Roadmap Europe project. My name is Rasmus Lund, and I'm a part of the Heat Roadmap Europe team at Aalborg University. I'm here sitting with Susana Paardekooper and John Kabatsanakis, also from the Heat Roadmap Europe team at Aalborg University. This podcast here is a part of the series, as I said, and it will be recorded and published on the Heat Roadmap Europe website and YouTube channel, so you can watch it afterwards. There you can also find the previous webinars of this series and other Heat Roadmap Europe relevant videos. Today's webinar with the title Heat Roadmap, a roadmap for regions with deteriorating heating infrastructure is the 5th out of 8 webinars this fall, and it's the number 12 in total of the Heat Roadmap Europe webinar series. There are 3 webinars left this fall, and in the end of the presentation today, I will show you a list of those and the dates, so you can see that. If you have any questions during the webinar today, you are welcome to type them in the webinar menu you have on your right-hand side. There is a menu where you can post questions, and then in the end of the webinar today, we will go through some of these questions, depending on how much time we have, and discuss that here. So going to the agenda for today. First, I'll give a brief project introduction. Most of you probably will know the project somewhat by now, but just to keep everyone on board, we have a short introduction of the project. And then we will go into the matter of today's topic and look at why this is relevant and which countries or regions we are looking at. Then we will have, or then Susana will take over and take you through very briefly the methods and then the results for these countries in this topic for today. And then in the end, I will briefly summarize the conclusion, recommendations and conclusions, and take you to the questions and discussions session. So that's the agenda for today. First, the purpose of the Heat Roadmap Europe project. It's a project that has been going through a number of different steps, where this is the 4th one in the series. But generally, the purpose is to create scientific evidence to support long-term energy strategies at local, national, and EU level to empower the transition to a low-carbon energy system, as it's written here on the slide. And then by quantifying the impact of various alternatives for addressing the heating and cooling sectors. So that is really the overall approach and the idea for what this project should be able to do. I mentioned just that it's the 4th in a series, and just to outline where the project has been going through the years. The first project was really focusing on what role district heating should play in the decarbonization of the European energy system. Whereas the second one took it also to look at the balance between savings and supply, so the combination of district heating and heat savings, and of course found that the combination is also relevant. In the third study, also known as the Stratego project, the focus was on low carbon heating and cooling strategies as of for this 4th project, but this was on a lower, you can say, level of detail in many ways, and only for 5 out of the 28 member states. So for the current project, Heat Roadmap Europe 4, it's really focusing on it's much broader, both in terms of data foundation, but also a number of countries that we are analyzing. So this is really when we cover 90% of the heating demand by these 14 countries. So it's almost the whole thing we cover. The series is the Consortium. Many of the faces in the picture you can see has been replaced during the years, but we still have this big team, strong, and we are really trying the idea with this consortium is really to combine the skills and expertise across different disciplines within the heating sector. So that we have some, for example, from mapping and for details of the heating sector details and saving potential and so on. So that is the reason why we have this relatively big consortium for this project, but it has shown really beneficial in the project. A little bit to look at the relevance of this this project and the series of projects, because the heating sector has historically gotten less attention than, for example, the electricity sector. But we have found or shown here that heating and cooling, actually the thermal demands, as we call them, cover 50% of the total demands, including all energy demands. So out of this, about half is space heating, and then we have some process heating and hot water and other demands. And if we look across the countries, we can see that there are actually thermal demands, both heating and cooling, but the heating is really the main part of the thermal demand, and the heating demands are present in all the countries, not only in the northern countries. So even in Spain, Italy, and so on, there are some thermal heating demands. The Heat Roadmap Europe project has, of course, generated a lot of results during the steps, and it has been found that the decarbonization of the European heating sector, that is possible, and also now in the current project we have found that the Paris Agreement can be met by already proven technologies. And it is technically possible and socioeconomically feasible to do this. What is also one of the key outputs is that the heating is really a very local thing. It's very closely connected to the local conditions. So depending on the local settings, different solutions are feasible. So, so very briefly, we have found that energy renovations are really feasible almost everywhere, but in the urban areas, particularly district heating systems or district energy, also cooling systems are relevant to consider, whereas in the rural areas, heat pumps is the main technologies that we see as feasible for covering heat demands in the future. So just zooming a bit more into today's topic of the countries with deteriorating thermal infrastructure or heating infrastructure. Why is that even relevant? We have some countries here that actually have some district heating systems already in place, but these need to be improved because of they have losses, and they have not been maybe always maintained properly, and it is generally just old. So there need to be some renovation of this going on at the same time as also the building stock need to be renovated. So this need to be coordinated, and therefore new planning practices and new efforts within the planning of the heating sector will need to be included or taken into the planning. and then also new heating technologies and heat sources will have to be considered in the heat supply. So therefore, this here is a map that shows the level of district heating coverage of today's domestic or residential heat demands. So here you can see that Scandinavia is the darkest green, and the highest share of district heating, about 50%, and then the shading goes down to the yellow, which is almost no district heating. So we have like a spread from Scandinavia with the highest, and then to Spain, and then some UK and so on with the lowest. But in the middle, we also have these countries mainly in the central eastern part of Europe that actually have quite some district heating. But there are some issues related to this because it's relatively old technology, and the infrastructure itself is also old, and in many places it's deteriorating and needs some renovation. These countries, just to mention some of the countries of examples of what we are talking about, we will have some graphs and so on, concrete examples from some of these countries during the presentation as well. But Poland, Romania, Hungary, and Czech Republic are examples of these situations that we describe here. So here are some images of what we are talking about. In a minute, I will talk about fourth generation district heating and previous generations. So this here is really some images showing the issues that we are dealing with right now in these countries and what we mean by deteriorating heating infrastructure. So here you can see that the pipes are these are district heating pipes, which is the supply line and the return line, always in parallel here. So the pipes are put in a concrete duct underground and then wrapped with some mineral wool in this case. So this is really how it has been done widely, really many places in these countries. And in many cases it has worked really well, but just as I said, this technology is outdated by now. There are much better technology available, and also these pipes are just old, and there are many leakages, as you can see in this in the figure here. And because of many leakages, the supply and distribution itself can get unstable and unreliable. So that is really a problem. This is a picture showing how new district heating pipes would look like. So it's basically steel pipes as the old one, wrapped in insulation, but instead of the concrete duct, it's wrapped in a plastic shell to protect it, and then the pipes are just put directly in the ground, and that's easier to install on the site, and it's also in terms of manpower, it's less costly. So this is what we expect of the future district heating pipes to look like. So looking at the countries again, and to see where in this chart we are looking of today's countries. The graph here shows the district heating shares on the x-axis, and then renewable energy share in heating and cooling on the y-axis in percent, both of them. You can see there is a slight tendency that the more district heating, the more renewable energy. It's of course a few examples only, but there is this tendency. The countries of today, they are located actually close to one another here. So you can see they have some district heating between 10 and 25% today, it's a little bit different depending on how you calculate the percentage, but it's in this region. But you can also see that they have relatively low share of renewable energy, so that's also something that should be in the focus. So last figure here, that is showing what we when I mentioned the fourth generation of district heating. This chart here shows the development of district heating technology. So starting with the first generation of district heating, which is steam-based district heating, very high temperatures and relatively low efficiency because of high losses. And then the generations of district heating is, you can say it's a continuous development where more technologies are included and the pipes are getting better and better, and the temperatures in the pipes are getting lower and lower. So the countries of this webinar and the results of that you will see in a minute is what we characterize as second generation district heating, where the pipes are like built on site in situ, as it's called here, and it's a relatively simple mix of heat sources, often fossil fuel based supply. This should be developing in the future, because what we see and what we are seeing in the research of within district heating is that in the context of a renewable energy system where we have 100% renewable energy in the total supply across all energy sectors, it's very important that district heating plays a much more flexible and dynamic role in the energy system to be able to interact with the electricity system, for example by CHPs, as is present already today, turning up the production and utilizing the excess heat from the power production, but also a technology as heat pumps. Large-scale heat pumps is really important when we have a lot of wind power, for example, to be able to, in times where we have a lot of wind power, to be able to use that in an efficient way for something that we would also need instead of needing to store, for example. And also heat pumps, they use a low-grade heat source and boosting it to a temperature that can be used in district heating, and thereby the efficiency of the system, the overall fuel efficiency is highly improved. So this is really what should be the aim for the coming development in these countries, is at least our recommendation to aim for fourth generation concepts and ideas of when planning for the district heating supply. And now I'll give the word to Susana, who will tell you a bit about the methodology and some of the results here.
Indeed, thank you very much. As Rasmus said, before we talk about the results, it's useful to give a brief overview of the methodology. The aim of this webinar is not to make you experts on how exactly we did it, but it provides a bit of a background so that you can understand where our results come from, particularly for these countries. So what we've done in Heat Roadmap Europe is combined several different approaches in order to be able to make the scenarios and make the roadmaps as we have. The first element is that we've done a very in-depth profiling of the different types of heating and cooling demands that exist and that will exist in the future, using forecasts, so looking at where heat and cold will be used, at what kind of temperatures heat and cold will be used, and in what kind of ways it's looking towards being produced. Based on that, we've then also been able to look at the savings potential for delivered energy. And that's been a big part in helping us show what kind of energy efficiency in the built environment and industrial processes is cost effective and is viable, and be able to bring that side of energy efficiency into the equation. The second thing we've looked at is the spatial part of heating. Heating is a bit special from other types of the energy sectors and other parts of the energy system. Together with cooling, it's much more local than, for example, electricity and transport. So in the Pan-European Thermal Atlas, we've spatially distributed all the heating and cooling demands using top-down regression-based methodology. So that's allowed us to see where the heating demands are and where the cooling demands are and at what kinds of density. And then based on that, we can start looking at what the costs of thermal grids and thermal infrastructure would be. The way that we then combined all of these together is in an energy system analysis, and we've done that using two models. And that allows us to look at the heating and cooling system in the context of the wider energy system. So within the context of what is happening in a deeply decarbonized electricity sector and what's happening in a deeply decarbonized transport sector. And that becomes very important, as you'll see, and as Rasmus mentioned within 40H concepts, that these things become a lot more integrated and reliant on each other in order to be able to function efficiently. So it's important to be able to see the heat roadmaps within the context of the other sectors so that we can make sure that everything works together well and we're not using a silo approach to decarbonize just one of them. So based on that, we've then developed a series of scenarios. The ones that you can see here and the ones that we'll talk about most are the baseline. We've made a baseline both for 2015 in order to show what the situation is today. Methodologically, that's useful because we can kind of make sure that everything is working and that it is as it was in 2015. But also a baseline towards the future, seeing what would happen if the current policy approach is maintained. So where will we get if we use what we have now? And then, of course, these alternative heat roadmap scenarios where we've changed the system and we've redesigned the heating and cooling sector. We've taken into account changes and we've tried to integrate as much renewables in the electricity sector. And we've worked with the decarbonization of the transport sector as it looks now in most baseline systems and most conventionally decarbonized systems. And then from there, develop these scenarios that we recommend as a way forward for heating and cooling. Of course, in this case, specifically for the Eastern European countries, but we have them for 14 European countries. And based on that, we've worked towards a European heat roadmap. So just one final point, the way that then we can start looking at these scenarios is typically in terms of primary energy supply. We use that as a measure for efficiency because the project is really set up around exploring the different ways in which we can use energy efficiency and quantifying that. CO2 as a measure for decarbonization, cost as a measure for affordability and competitiveness, which is something that we would like the European energy system to be and stay in the future. But also some more detailed things that we can start looking at the different types of fuel that are being used. Because we use an hourly model, we can break that down in quite a lot of details. So those are the kind of results that we can then start looking at and start comparing along. As I said, the objective is not to talk at length about the methodology. So if you're interested in more about this, then we have a few background reports, both for all these 4 individual models, but also generally on the website. So what does that bring us to? When we use these different kinds of methodologies, we've started to bring these roadmaps together in the form of scenarios. What we see across all the scenarios is that we can bring a reduction in primary energy supply. In the figure that you've got, that basically means that the large blue-gray circle is smaller in the heat roadmap scenario to the right than it is currently today in the baseline. That's done both through improvements in efficiency on the demand side, so in terms of both the building stock but also industrial processes, but also by making the delivery of that heat more efficient, typically through the provision of thermal networks and being able to recover different types of heat. The second thing that we notice is that there's an increase in the amount of electricity supply that happens. As I mentioned before, we see this within the context of a largely decarbonized system. So it's a heating and cooling project that we're doing in Heat Roadmap Europe, but it's relevant to understand that as the transport sector decarbonizes and as the fuel production undergoes some radical changes, there's a lot more electricity being used. You can see that because the kind of pie chart in the middle is larger on the right. And that's an important thing to take into account, because when we want to decarbonize heating and cooling, we need to understand that electrification in and of itself is happening within the context of those other electrification processes. So what we've ended up doing in Heat Roadmap Europe is really looking also at thermal grids. You can see that in the light green spot in the middle, as a way to both bring efficiency into the system in terms of being able to reuse different types of energy that would otherwise be wasted, in terms of being able to access renewables that otherwise wouldn't be available, but also in order to really be able to balance and play with that high level of electricity and the flexibility that's required within a future system. So overall, this brings us to a scenario which is almost 90% decarbonized compared to 1990 levels. That's a bit of a strange reference, but that's mostly used so that we can show that this is in line with what is currently the ambition of the European Union under the Paris agreements. And that's important because almost all of our effort here has been on the heating and cooling sector. We've looked a little bit at the different types of variable renewables and the balance between power plants in the electricity sector. Other than adopting conventionally decarbonized systems, we haven't done very much to the transport sector. So just by using proven technologies, we are able to bring a very deep level of decarbonization to the European energy system through this combination of efficiency and thermal grids. So that's an important finding overall. As we start to dive more into the countries where we're looking to modernize the systems and where we have this deteriorating heating infrastructure as it is, these concepts all hold true. You can find them for the individual countries as well. So it's important to understand exactly what that interplay is between, on the one hand, the efficiency on the demand side, and on the other hand, the efficiency on the supply side. So when we talk about the heat savings, to take the first one, the efficiency on the supply side, what we see for the countries that we're talking about today, Poland second to the right, Hungary, Romania, and the Czech Republic, is that the potential for savings within the overall sector are very high. Compared to today, we're looking at savings of over 25%, and in some cases, almost up to 45%. Again, that's also higher in most cases than what we see for the 14 European countries that we looked at. And that is typically the result of both a building stock that has a very low standard for the specific heat demand, so typically an old building stock, and one of a lower quality. But at the same time, that also is an indication of in some ways, the idea that the efficiency of buildings and the efficiency of industrial processes has only really been a focus in terms of policy and in terms of improvements for the last 30 years. On the one hand, that seems like a long time, but on the other hand, when we look at the lifetime of buildings and the lifetime of some of these process heating installations that exist, that is not a very long time. So it doesn't really compare to the lifetime of these things. What that also means is that there is a lot of potential to move forward. So there's a lot of buildings that are due for renovation. There are a lot of industrial processes that are due for upgrading. So there are a lot of improvements to be made. One of the things that we'll talk a lot about is that in order to be able to make these heat savings most effectively, it is worth combining it with the savings on the district heating side and the renovations and the reconstructions on the district heating side. As I said, this is something we'll come back to, but it's important to note here as well that the change in delivered space heating demands can really have a synergistic effect with the change in the efficiency of the distribution systems. To go into a little bit more detail, we'll look specifically at the different types of thermal demands that we're reducing. Most of the ambition in the way that it stands, as you can see in the middle column, which is the baseline for 2050. As I mentioned, this is a kind of current policy. It's not a forecast, but projection towards the future compared to now, is in the space heating. On the one hand, these are very ambitious levels. On the other hand, this is also an area where a lot of the countries that we're discussing today have had a lot of improvements in the past. and where there have been very high relative gains. But what we can see here is that if we look at the heat roadmap scenario, which is what we recommend in terms of really being able to bring deep decarbonization at an affordable level, is that the ambition should be higher, and that the efforts that are being put into the sector need to be increased. So we'll talk a little bit more about space heating, but just to point out here that process heating is not at all insignificant. It depends a little bit per country. You can see here that in Poland, it's much more important relatively than in Hungary. But there are almost no countries in which process heating is insignificant because it's such a big part of industry. And it's an area where almost all the savings that are possible are cost effective, but it's very difficult to make savings. At the same time, it's also a very important sector because it's a strategic sector in terms of economic growth. But as we really address these space heating issues, you can see that the process heating becomes proportionally more interesting. And that's also then where excess heat becomes proportionally more interesting. In terms of cooling, in all the countries that we looked at, but also in the countries here where we're looking at modernization, markets, and reconstruction, cooling increases. Of course, it depends a little bit per country, but even in Poland, which is typically kind of a fairly northern country and has quite harsh winters, you can see that there are space cooling demands, and a lot of that has to do with the service sector really realizing a lot of demands that exist. But it's not something that can be ruled out in any of the countries. So to look again specifically into the residential heat savings, which is where a lot of the space heating takes place, we can see again that these regions have a higher need for savings than the rest of the EU due to the issues that we discussed earlier, but also that the baseline as it currently stands, so the policy that is designed today, would lead us to the level of the blue bar in terms of reduction from the current demand, and higher ambitions are needed. What's quite interesting about the 4 countries that you see here is that we found really quite significantly different results than from the other 10 countries that we looked at. So since the scope of Heat Roadmap Europe is really to look at proven technologies and technologies that are being used today, we excluded from what we analyzed more experimental and more hypothetical kind of approaches and technologies and means of being able to achieve space heating demands. But in almost none of the countries, this was an issue. So except for these 4 countries, we basically found that the cost of achieving higher levels of savings was higher than the benefit that you get out of it at the very high levels. So it wasn't necessarily a problem that we excluded these more experimental types of heat savings. In the 4 countries that you see here, there is a potential that those technologies, which we didn't really consider, could be cost efficient, because the highest level of savings that we tested and the highest level of savings that we made were relevant for the final heat roadmap scenarios. So it may well be worth exploring those more experimental rates. In terms of the refurbishment rates, that's always something which is relevant for these heat savings. What we're looking at in these 4 countries is really doubling or tripling those rates. So where it now lies somewhere between 0.7 and 1.3 within the baseline, so within those kind of projections of where the current policy would bring us, that needs to pretty much double or triple in order to be able to achieve these levels of savings as we recommend within the heat roadmaps. So to round that off, basically the heat savings in particular, and particularly the space heat savings in the residential sector, are a very important part of the modernization effort in these countries, where when we talk about deteriorating heating infrastructures, we also need to recognize that the built environment is a part of that. And it's one of the main ways in which we can really achieve the efficiency that we're looking at and the decarbonization that we're modeling within the Heat Roadmap Europe scenarios. So to move to, in some ways, the other side of this coin, we started to look at the different ways of supplying the heating. And one of the main ways that we've looked at and that we've explored in this is by looking at thermal grids. From that, we've come to a share of district heating for all the separate countries, which is economically viable and which brings those kind of decarbonization and efficiency advantages that we try to explore in Heat Roadmap Europe. What you see on the figure here is the current in the red and the recommended levels in the form of the green triangles within the lines, which really represent a range of district heating that is, again, both economically viable and that contributes to the decarbonization and efficiency. We've put those 4 countries, the Czech Republic, Hungary, Poland, and Romania, but also Spain and Sweden, and then the HRE4 Europe 14 average, to give you a kind of comparison to work with. So what we see in these modernization countries is that the infrastructure is in many cases there, and most of them it's higher than the European average currently. So it's not so much an issue of expanding district heating as it is. It's more that the district heating that exists needs to change. Of course, the advantage of this is that, you know, the system is there. It's about transforming the system. If you look at, for example, Spain, then there is no current district heating. So the challenge that is being faced is very much about implementing these systems. On the other hand, it may be harder to transform these systems from what they are today towards what we're looking at in terms of a 3rd and 4th generation system. So when we look at this level of what the share of district heating should be, which we'll talk about before we talk about what the district heating looks like, rather. The potential for district heating is much more driven by the kind of spatial typology of the country than necessarily something which has to do with the district heating itself or with the built environment itself. When we look at the way that we construct that cost of distribution through the district heating pipes, then we do that by looking at a cost curve. And you can see 2 examples of these on the right. The top one for Poland, the bottom one for Romania. And those are driven by basically how dense the heat demand is. And that's much more driven by the spatial fabric and the urban planning practices in a country than necessarily something which has to do with very traditional energy planning. You can see at the top that Poland is in some ways fairly average. When you get to the higher shares, then it's a little bit more expensive to start expanding into the countryside. But if you look, for example, at Romania, then you see that the cost curve is significantly higher than the European average. It's actually one of the highest of the 14 countries that we looked at. And that has a lot to do with the fact that Romania is also one of the most rural countries when we look at the European Union. So there are cities in which there is a fairly high potential, but outside of those cities, it becomes very difficult to be able to achieve levels of district heating. So that's the kind of background as to what the different levels for the district heating are, and what that means for the different types of expansions that come with it. When we look at what the district heating is being fueled by, so what the district heating production is, then that's where really one of the more radical changes come. We kind of go back to this line of looking at a 2nd generation district heating system versus a 3rd and a 4th generation district heating system. But when we talk about the district heating in the HRE4 Europe scenarios, then we're really talking about something which is much more diverse and much more flexible than what exists today. So when we compare to what happens today, which is on your left-hand side, then we're really looking at CHP plants and fuel boilers. When we look at what we're recommending in the HRE4 Europe scenarios, then there's still a relatively high level of CHP. The difference is that these are much smaller and these are much more flexible. So they typically operate towards the electricity market, and the heat that's being used in the district heating systems is very much kind of a pure byproduct. The other heat is typically supplied by heat pumps. These actually form a really nice synergistic effect with the CHPs in order to be able to interact with the electricity system. Because the CHPs run on the demands of the power sector, when the power plants are not required there, then it's very easy to use a lot of the renewable variable electricity for the heat pumps in an efficient way. But we're also looking at a lot more kind of industrial excess heats. The ones that we've looked at here are the kind of traditional industrial access, and they don't necessarily need a heat pump in order to be upgraded. That's something which is possible in the future and something that we're investigating, but not considered here. What we did consider is heat recovery from the fuel production. As I mentioned, in the decarbonization of the other sectors of the energy system, we foresee a very high level of fuel production for heavy transport in particular, but also different types of industry. and that fuel production produces excess heat, and that is used. So there's a much more diverse mix of things that are happening. By having these CHPs play a different role, and by being able to look at the heat pumps and the electric boilers, we can have a much more interactive way of operating the district heating system towards the electricity system than what is really common within the district heating system as we see it today. So to look at that in a little bit more detail, you can see the percentages for the different types here. But that also brings us round to what is necessary for this to be able to happen. When we look at the different types of excess heat sources, as I said, here we only use the direct utilization. But if you could use indirect utilization, then the potential for that is much higher. And some of the sensitivity analyses that we've run show that that would contribute not just to the operation of the district heating system, but also make it more cost effective. In order to be able to do these kind of things, also with heat pumps without any type of uptake, but just using them straight from bodies of waters and rivers, as is the light green that you see in the graph, the temperature levels become very important because they start to dictate how efficient the system is, or how efficient the conversion technologies are in order to be able to produce this, and through that, how efficient the system is. In addition, some of the heat sources that we consider here, geothermal is the main example, are really only possible if the temperature levels of the system are relatively low. And of course, when the temperature levels of the district heating system are lower, then the losses are lower and the supply costs become lower. So what this all leads to is that there also needs to be an interaction with the built environment and with the places where this heat is then being delivered through the thermal grids. And that's where the synergy between, on the one hand, the energy efficiency on the demand side, so in terms of the built environment and in terms of the industrial processes, links with the changes that are required in the district heating system as they stand. What we've done here is really look at it at an aggregated and on a national level. But what would move forward from this is to start looking at that at a very local level. Of course, if you have an area where the demand in buildings is 120 degrees, then implementing these different technologies becomes very different. So the renovations that are recommended in the heat roadmap Europe scenario really need to complement the developments that are happening within this district heating sector, and vice versa. The developments that are happening here in the district heating sector need to be complemented by what's happening in the built environment. As you can see, there are very few slides left, so we're almost there. The last point to make about this complementarity between the energy efficiency on the supply side and the energy efficiency on the demand side is that that also makes things a lot more complex. So when we start using a lot more of these diverse types of heating supply, that also means that the way in which we balance them and the way that we construct these markets becomes a lot more difficult. So there's the temporality of the heat production. There's also the way in which the initial investment requirements are covered. So one of the things that we looked at in Heat Roadmap Europe was really about the investment costs that are required for this, and the different levels of capacity that are required within different system setups. And those are things where we really need kind of the market's uptake and the policy to be able to support these kind of recommendations. When we're looking at these transitions that we're making, as we mentioned, we really only use technologies that are proven and that are already being currently used. But it's also necessary to understand that an economy of scale can make all these things more cost effective and can bring better developments to a lot of these technologies that we're considering here today. We've been very conservative in the kind of learning rates that we've assumed and the ways that we've assumed technologies to change between now and 2050. But these things can change within a collaborative environment where a lot of research is being shared with each other. And that's also part of then the complexity of trying to bring together all these different types of technologies and different types of conversion rates. So one of the other things that we are kind of looking at And this is here because it's something that we've been working on since we finished the Hero Map Europe scenarios a few months ago, is that we really see a change from a few large producers. So as we saw earlier, a lot of systems are currently run by a few large CHPs and then some backup boilers, to a much larger variety of smaller players, and a much larger number of smaller players that include both the different types of excess heat, but also the heat pumps and the CHPs. What we've been looking at recently is trying to put that together with what we call unconventional types of waste heat. So the excess heat that comes out of the ventilation and the cooling of metro stations. Supermarkets is something which is really interesting because it's a place where you walk through a hallway of cold without really thinking about how those things are cooled, and that's one of the ways in which we could use excess heat that we really create within urban environments. So it fits really nicely with the spatial spread of where we have the heating demands and where we have the cooling demands. Sewage cleaning facilities, it's not really something we should explain in depth, but again, it's something which is really closely linked to urban geographies. And data centers. These are things that we didn't consider in Hero Map Europe. So if you look at the results and the scenarios that we have, this isn't something that is in those, but it is something that follows the line of thinking and follows the trends that we've been seeing in the Hero Map Europe scenarios that we made, and that we're currently exploring. So that hopefully gives you a brief overview of the results that we created within the Hero Map Europe scenarios. As I said, we have a lot more information on this, both in a variety of background reports if you're more interested in the methodological parts, but probably the most useful resource is that we have country reports on these 14 countries, including Poland, Romania, Hungary, and the Czech Republic. And there you can really see the country-specific numbers and the different results for the countries. So with that, I'll hand it back to Rasmus, who's going to give us some general recommendations in conclusion.
Yeah. Thank you, Susana. That was really a walkthrough of some of the main results in this in these countries and these areas with these specific issues. So just before we go to the questions, I'll just go through these very brief recommendations or conclusions, you can say, of these heat roadmaps for these countries. So one of the main recommendations is that the renovation of district heating systems should be done in accordance with the renovation of buildings, as we saw that district heating systems need to be renovated, and at the same time there is a big need for renovation of the buildings with a focus on energy, and this renovation can benefit a lot from being coordinated. So in towns where the district heating system is being renovated, for example, for low temperature district heating, a renovation of the buildings will, you can say, they will mutually support each other when doing it in parallel, you can say. So if that is possible, then that's a big, can be a big advantage. And then to develop towards district heating of the fourth generation, as we talked about in previously here, it's important to consider many more new heat sources for supplying heat. So not only sticking with the conventional ones, and particularly heat pumps opens up for a large variety of new heat sources, low temperature heat sources, where heat pumps can be used to boost the temperature of these to improve the efficiency and use new renewable or waste heat sources that are available in cities or other places. And then the last recommendation here is to promote the integration between energy sectors. In the planning for the district heating, it should be kept in mind that the integration is very important for the overall system efficiency of the energy supply, so that the heating is not planned for itself and electricity for itself and so on. Because, for example, if the CHP plant are designed to operate both on heating and electricity systems, they can work and contribute to both sides. And if, for example, industrial activities are placed in areas where there is a district heating system, or activities in general, for example, let's say fuel production for transport is placed in areas where there is a demand for heat, then the excess heat from these activities can be used in district heating, and thereby improving the overall efficiency and reduce the primary energy demand for the overall energy supply. So these are the main recommendations for this. And with these notes, I will end our formal presentation and go to the questions sections. It looks like we don't have any questions right now. So if you have any, then please write them now, and then we will have a look at it. Yeah, before maybe while you do that, I'll just give you the headings of the coming 3 webinars. We have the one on the 15th of November, which is about cooling. It's called Cool Roadmaps in Europe, and will be hosted by Susana. Then number 14 here is on what we call strategies for countries and regions with underrated heat demands. So that are also countries with without much of a tradition for heat planning and not a lot of district heating, for example. And then the final webinar called the Heat Roadmap Europe Final Outcomes Guidelines for Users will also be with Susana. So that is the plan for the remaining part of the webinar series here. We have 3 questions now. What can other countries learn from this? I think, of course, we have divided these results into to different, you can say, overall issues. So I think countries that are similar to these countries or have some of the similar issues, they can also learn from these results. But I think in general, the points about 4th generation district heating and renovation, that renovation needs to be performed, that these 2 points are important. And of course, also, we didn't talk much about individual heat pumps today for the rural areas, but I think these 3 points are kind of general points that other countries can learn from. I don't know, do you have anything to add to this?
Yeah, I mean, I think that when we describe them as areas with, deteriorating heat infrastructure, if you're outside of these countries, but there's an existing district heating system with high temperatures, fairly kind of basic different supplies that resemble the 2nd generation more than a 3rd or a 4th, then what we've talked about here for these countries can also apply for that city. It's it's not specifically bound to those areas. So the second one is specifically about heat pumps and what their role is within the district heating supply mix. I think that also refers a little bit about this link between the electricity sector and the heating sector.
I think one of the most important parts or roles of district heating heat pumps is really to bring in some heat sources to the heat supply that would otherwise not be possible technically to use, because if we have some sewage water, for example, of 15 degrees or 10 degrees, it's too low really to use in district heating, where we have a supply temperature of, let's say, 80, 90 degrees maybe. and even in low temperature district heating, where we might only have 50 degrees, it still can be used unless there is a heat pump to boost the temperature and thereby utilize this potential excess heat for heat supply, and thereby replacing fuel or other primary energy sources that would have been used to cover that demand.
Yeah, I think the other thing we talked about already, that if you have this combination of cogeneration, so electricity production in the different hours where there are not enough variable renewables, and then heat pumps which can absorb a lot of the electricity in the hours where there is excess variable electricity, it really means that you can use the renewable capacity that you have a lot better. So if you have wind turbines and solar panels, either centralized or distributed on roofs, then you can use that capacity better, in the sense that you can use them for more hours in the year, and that electricity can be kind of diverted into the heating sector. So I think that that's also a really important role for these heat pumps when we talk about them.
Mm-hmm.
The third question you kind of already answered, but it was about the heat demand that is not covered by district heating, how we see that within the heat roadmap scenarios.
Yeah, I think the main solution that we propose in the heat roadmaps is individual heat pumps or building scale heat pumps. But of course, it's a very big variety of different kinds of buildings and demands and so on. So it's a bit like idealistic solution that we can use heat pumps in all cases, because that will probably not be the case in real life. So it will most likely be a mix of, also we have some, like, let's say, biomass boilers, or in here and there, or maybe even a little bit of biogas, I don't know, but it will probably be a mix of some different sources. But we propose heat pumps because it plays this role of integrating the electricity sector into the heating, and therefore like reducing the need for fuels for heating, which is really important. So that is our main proposal, and yeah, the most feasible solution we find from our using our methods. Yeah. Okay. I think that was it for now. These are the questions we got, and thank you all for attending this webinar, and have a nice day, and see you in some of the coming webinars, hopefully. Yeah, thanks for attending. Goodbye.